Hey, welcome back, and in this video I'm going to show you how to get started with Google Cloud Run, which is Google's serverless container runtime environment. And what we'll specifically do is we'll build a web application in Rust, we'll get it containerized, we'll build it with Google Cloud Build, and then we'll deploy it onto Google Cloud Run. So before we get started, what do I mean by serverless, and when would I use something like Cloud Run over App Engine or Cloud Functions? Well, serverless doesn't mean there's no servers. It means that I'm no longer thinking about or worried about the underlying infrastructure. I'm handing that responsibility across to Google to manage on my behalf. What I am responsible for is I will build myself a container, because Google Cloud Run is a container runtime environment. So I will build a container and then hand that across to Google. Now, Google will then decide what machines they will run that container on. So as you can imagine, Google's going to have lots and lots of data centers. It's going to have loads and loads of machines in their environments, and then it's going to move that around. It's going to reallocate that depending the load on their data centers, and they'll decide which specific machine that's going to run on. That becomes their responsibility. It also means that I have the ability to scale. So if I am not managing that infrastructure and then I get more traffic than I was expecting, then I can have scale up policies or scale down policies, so that then Google says, okay, there's too much traffic here, and then it's going to spin up new instances and put that on other machines within its network, right? Whereas if I don't have something like a serverless environment and I'm responsible for my infrastructure, then that means I can only scale within the machines that I have, right? But in a serverless environment, it means I've got the vast array of Google machines to become available. That also means, from a redundancy perspective, I also have the advantage that if things start to go down, so maybe I lose the machine that my container is running on, then Google will automatically spin that up on another machine. But it's not only machine level redundancy, it is also data center level redundancy. So Google has these things called availability zones, where they can have multiple data centers within an availability zone. And if an entire data center goes down, then that container will spin up in another data center. So you can deal with entire data center losses. And I'm not worrying about that. That is Google's responsibility. They will take that if that data center goes down, and then they will spin it up somewhere else. So I've got this sort of fault tolerance capability that I'm getting for free from Google. But not only that, as I said, with the scale up and scale down, then I also have other advantages, like I could actually scale down to 0. And that's one of the big advantages of serverless. So if I want to, and I don't mind the cost of spin up time, then if I'm not getting any traffic, then my server can, or my container can, spin down completely and not be running, and only be invoked when the first request comes in, and then it can spin up and then serve that request. Of course, I'm paying a latency payoff at that point, so I may decide actually I want to have a container running all the time so that I have fast responses, but then that is my choices within that management of that environment. So serverless gives us a lot of advantages. It means we're no longer thinking about the infrastructure, we're placing that on the infrastructure providers. We have that ability to scale up massively and scale back down again, but we also have that fault tolerance and redundancy, as well as a whole load of other services that come part of that solution. So it really is simplifying the estate, and I can focus on building my application as opposed to managing infrastructure. Okay, so you're probably thinking to yourself, okay, that sounds cool, serverless sounds great, so why wouldn't I use something like Google Cloud Functions? Well, there's probably a good few reasons. So a good example is that Cloud Functions only has a certain number of runtimes and frameworks supported. So at the moment it supports Node.js, Python, Go, Java, .NET, Ruby, and PHP. So if you were wanting to use a language or a framework outside of that, then you're not going to be able to use Cloud Functions, and then therefore you need to choose something else. So Google Cloud Run would be that natural choice there. So for example, if I want to build a Rust application or a Dart application, then they're languages that are not currently supported by Cloud Functions, and therefore if I want to have a serverless way of hosting my application, then I would pick Google Cloud Run. And actually, for fun fact, and it's probably obvious if it's not obvious already, is that Cloud Functions is actually built on top of Cloud Run in itself. So basically, for those languages not supported, you're going to have all the advantages of Cloud Functions. It just means that you have to do a little bit more work because you're going to have to build those containers in the first place. Now, a second reason is maybe if it is a supported language, so let's say it's something like Node.js, and you want to use a framework other than the framework that's supported by Cloud Functions. So in Cloud Functions case, if you're building a web server, then it's actually built on top of Express. So if you wanted to use something other than Express, maybe you wanted to use Fastify, for example, then you would be able to use Cloud Run in that sense, because you wouldn't be able to really use Fastify as part of Cloud Functions. So that's about you then moving into Cloud Run and then managing the application framework yourself. And then probably the third scenario is that if there's something that you want to run as part of your application that really isn't sort of function based, so maybe you're doing a video conversion, maybe rather than a web server, I'm doing event driven messaging of some sort. So maybe I'm wanting to listen to some events, and then once I receive an event, I'm going to do something like maybe doing a video conversion, and to do that video conversion, I might be using a tool such as FFmpeg. Well, installing that application isn't going to be easy within Cloud Functions. In fact, let's say, never mind, not easy, not possible. Then what you could do in that sense is take your FFmpeg application, run that within the context of Cloud Run in the same way as you could run a Rust application, Dart application, and then you can manage that in a serverless way. So that's the sort of main scenarios of why you would use Cloud Run over something like Cloud Functions. And in this video, we will focus specifically on the web application scenario and the non-supported application framework. So what we will do in our case is we will build a Rust web server, and we will then run that in Cloud Run. Of course, if you're doing something else like Fastify or a Dart application, then everything I'm going to show you in this tutorial you'll be able to use as well. But of course, in this particular case, we are focusing on the Rust application, but everything else remains true. And just before we get started building our application, if you are interested in something like Google Cloud Functions, then I have done a video on that, and a link will appear in the top corner there. Okay, with that being said, let's get started and we'll build our Rust application. Okay, so first things first, what we're going to do is build ourselves a little web server in Rust. In fact, we're going to use the actix-web framework. If you've never used Rust before, I do have an introduction video, so check that out. It should appear in the top right hand corner, but this is fairly self-explanatory and very quick to kind of follow along. But that video will show you how to install the various tools you'll need, like cargo, etc., and how to get Rust installed on your machine. So to create my new project and scaffold it up, I would just type in cargo new, and we'll give it the name Cloud Run Actix Hello. So that will be the name of our application. We'll just hit return, and then what it will do is scaffold us up a brand new application. So if I just type in ls, you can see my Cloud Run Actix Hello has been created, and within there you can see it's scaffolded up some stuff like the cargo toml file and my source directory. So if I just type in code dot, and that will open up the application in Visual Studio Code. And to get started with actix-web, all I'm going to do is open up my cargo toml file, and then we'll add that as a dependency. So we'll just type in actix-web, and we'll put the version. So I think at the moment it's version 4.01, and we'll just hit save. And if you look at the ticks there, it'll come up with the various versions that are available. You see 4.01 is the latest version. So I will just save that. And then what I will do now is if I go into my source folder and I open up the main.rust, you can see it's got this hello world there. It's just, in fact, if I was to just go back into my terminal and I typed in cargo run, you will see it will build the application, then that will just come back with hello world. As you can see, it's built now. It's a fairly slow build. It's taken like 46 seconds to build that, simple hello world, but it's going to compile all the packages, etc. But you can see it's came back with that hello world. And in fact, if I run cargo run one more time, it should be a lot quicker now because it's been built already, and it comes back with that hello world. Okay, so what we're going to do now is we're going to get rid of that hello world application, and what we'll do is put in our actix-web-server. So the quick way of doing that is actually if we just go to the actix-web website. Let me just make that a bit bigger. So if we go to actix.rs, you can see it's got a nice little sample there. So if I was just to copy all of that, hit Control C, go back into Visual Studio Code, and then replace this here with the code that I've copied from the web server, and then hit save, then that's gonna work there. Now you can see it's came up with there is no argument named name. So if I just remove that here and then just put comma name, that will work. So what is actually happening in this? So in this case, it's spinning up an HTTP web server, as you can see there. It's binding to 127.0.0.1 on port 8080. Now for Google Cloud Run, we're gonna have to change that, and I'll show you that in a second. And then what it's gonna do is run a web server, and that's pretty much it. The only other thing to notice here is you can see it's got this route and service here. So what's gonna happen is it's gonna route anything that is going to /hello. It will default to hello world. So if I was to call localhost hello, it will come back with hello world. But if I was to pass in hello /name, so if I put Chris, then it's going to come back with hello Chris. And you can see that there's a little bit of decorator magic up at the top there, which is putting the path for a get. So if I put in hello whatever her name is, then as far as routing is concerned, it's going to then use this little format, so it goes hello Chris. So if I just save that and we come back to the terminal, let's just clear this, and if I do a cargo run again, it'll take a few seconds because it's going to have to build all of those packages, download them, but that will then, once it's built, start that web server, and then we'll very, very quickly test that working. Okay, so as you can see, my web server is now up and running. So if I was just to open up a browser, and if I go to localhost 8080, I think was the port, and we put in /hello, then it's going to come back with that hello world, which it does. And as I said before, if I was to add in something like Chris here, then it's going to come back with hello Chris, which it does. And then I could change this to anything. I could put Fred, and it could say Fred, or I can say Jemima, and it comes back with Jemima. So that is a nice working application. Okay, so before I can take this application and containerize it and push it up to Google Cloud Run, I need to change a few of these things. So the first thing is I can't use 127.0.0.1 because anything that is containerized needs to be hanging off an unbounded address. So what I actually need to use in this case is 0.0.0. So the next thing you need to know about Google is, from a port perspective, it actually does default to port 8080, but Cloud Run wants the ability to control your application via environment variables, in fact, specifically the port. So one of the things we need to do within our Rust application is have that ability to support being able to change that port by environment variables. So that's what we're going to do just now. So to do that, I'm going to introduce a new variable, and we're going to call that port. And what we'll do is, so we'll just say let port equals, and what I want to be able to do there is handle defaults, etc. So what I'm going to do is I'm going to go and have a look and see if the port environment variable is there in the first place. So what we'll do is we'll use the match keyword in this case, because what we're going to do is if the environment variable isn't there, then we're going to default back to 8080. So we'll do match, and we're going to look at standard end, and that's how we get access to our environment variables. And particularly, I want to look at var. Okay, and then what I'm going to do is look at the port key, and then if we have a match, so I'm going to say okay on port, and if I have that, then we will pass through port. And if there isn't a match, so let's imagine that particular case where we don't have an environment variable called port already, then what I want to do is default to 8080. So in that case, my default is going to be a string from, and I'm going to put 8080 as my default. And then we will just terminate that there. So just to go over what that's doing there is I'm going to create myself a new variable called port. And then what I'm going to do is I'm going to do a nice little match there. So I'm going to be looking for the environment variable key called port. If port exists, so if it comes back okay, so I have success on getting a hold of that port key, then what we will do is we will use the port. So you see a nice little arrow function lambda there that says return me the port. Okay, so now that I've got the port defined, what I ideally want to do is get rid of that 8080 and then pass in an address with the port as part of it. Now the easy way of doing that is for me to create a new variable called address, and what I'm going to do is use the format macro. And what I will now do is take that 0.0.0 and then I will pass in the port as part of that string format. So I'll just put in our brackets here and now put port, and that will give us an address of 0000, and I'm going to be taking that port and passing that through there. So I've now got my address, and now what I can do is get rid of this, and then I can just put in my address. But of course, what I'm gonna have to do there is clone that so that I can do that binding. So now I've got my address through, and now it's in a sort of format that can be used for containerization and be able to run on Google Cloud Run. And in fact, if I wanted to test that out, I could go back to my machine, and I could type in something like export port equals 3000. And now if I do a cargo run again, what it's going to do is start that up on port 3000. So if I just do that, cargo run, it'll take a couple of seconds to get that running, which it's now done. Come back into my browser, and now rather than going to 8080, if I do localhost 3000 and then put in hello, you can see now it's working with the 3000 rather than the 8080. And then if I just put in Chris, for example, I'm back to hello Chris, or say Jimmy, hello Jimmy. So now my application that was running on 8080 is now configurable, and I can just change the port via environment variable, and that means it is now ready and running to be put on Google Cloud Run. Okay, so the next thing I want to do now is containerize that application. And to do that, what I need to do is create myself a Docker file. So I'm just going to put in Docker file, and I'm actually going to paste in the multi-stage Docker file that I've got. It's quite a large file, so you can kind of see it's in a lot of complicated stuff because I'm using a tool called Cargo Chef, which allows you to create multi-stage builds. And in fact, I have a whole video on how to create super fast Docker images that are secure and small and performant. I recommend you check that out. That will be appearing on the top right hand corner, because I go into great detail on why multi-stage Docker files are important, why it speeds up, how it keeps your images small. But I'm not going to go that into this video, right? Because it's like a 40-minute video on how all of that works. But the main thing that I want you to see is that I'm going to take this application that we've built here, and we're going to create a Docker image from that. And in this case, we will call this, what did I actually call this? Let me just come back into my machine. We called it Cloud Run Actix Hello. So we'll just modify that so that we've got the same name. It's not actually important, but I just want to make sure that we're sort of running similar names within here. So, and then the last thing that I'm going to need before I do my Docker build is I'm going to need a .docker ignore file as well, which is very similar to a git ignore, but it just means that we're not going to take any files such as the target files, .git files, or any of that sort of goodness into our Docker images, and therefore we can keep our Docker images fairly clean and build them from scratch. And the target folder, just in case anybody is unsure what that is actually over here, and that actually contains where all your builds are done. So as part of the build process for the Docker images, what we will do is build using the multi-stage cleanly the application, and then we'll copy the final built application into our very small Docker image that we're going to create. So we want to ignore anything that's running on our machine and then essentially build that from scratch. So that Docker ignore is just to make sure that anything I built locally on my machine isn't brought across, especially that target folder. So we'll just save that, and now what we can do is build our Docker image. Okay, so what we'll now do is build our application. So to do that, we just run the docker build command. So I'll just type in docker build, and then I'm going to tag my image. I'm going to put it in my sort of Chris Hay UK repository, but later on we will change that when we set that up to go onto Google Cloud Run. So I'll give the name Chris Hay UK, and then we will use Cloud Run actix hello, which is the same name as we used earlier, and then we'll just put in dot, and that means go build what is in the current folder. It will go and build that application. So it's going to take a little bit of time to get that built because it's my first build, and then once that's built and ready, it should be a lot faster because of the multi-stage build that I'm doing. And again, go check out that video. It'll explain how you can build your applications pretty quick. As you can see, that is now built, and you can see it's taking a long time. It's like taking 220 seconds to build that application, and that is the problem with Rust applications and Docker. It takes quite a long time, and that's why we use that multi-stage build, because what we mean in that case is the first build is going to be slow, but after that all the caching layers are going to make that super fast. So if I ran this again, you're going to see that it runs almost instantaneously. In fact, if I even made a change to the code, so if I come back into my application, so rather than it saying hello in that particular case, if I put hello and then hit save, now when I make the application, it's going to use all the caching layers for all the dependencies, etc., and it's only been built in the application part. So that Docker build, if we just run that there, you can still see that it's taking literally a few seconds to get that built, as opposed to the sort of 220 seconds that it took before. So in this case, it took 7 seconds. And again, if you want to deep dive that, go check out that video, which will explain how all that multi-stage build works and how to speed up your Rust application, and then you can be running on super fast builds like I am. Okay, so my Docker container is built now, so what we need to do is we'll just run it locally, make it sure it works, and then I'll show you how we can get that built and deployed on Google Cloud Run. So to do that, I'm just going to type in I'm just going to clear my screen, and then I'm going to type in docker run, and I'm going to expose port 8080 because remember that was the default on the application that I built. And then I'm going to use the tag that I had previously, so that was Chris Hay UK, Cloud Run actix hello, and then if I just hit return there, then it will spin up that Docker container. And then if I were to go to my browser, we'll just get rid of this, and then if I type in localhost 8080, and if we put hello, then it comes back with hello world. And then of course, if you remember, when we pass in a parameter string, it now says hello. So if I just let's type in let's put in Sandra. So if I put hello Sandra, you can see it comes back with hello Sandra, so you know it's the latest working version that you've got, and it's all running on 8080, and it's been served up from my Docker container. So everything's been containerized now. So what we're going to do now is take our Rust application and move it onto Google Cloud Run. Okay, so to do that, there's a couple of kind of prerequisites that we have, so I'm just going to clear out my screen there, and you need to install the Google Cloud SDK. So if you haven't done that before, you can just type in curl https and go to sdk.cloud.google.com and then pipe in bash, and then if you run that, it will download the Google Cloud Shell and all the SDK tools that you need to get that installed. So if I just hit return to all of that, as you can see, it says I've already got Google Cloud SDK installed already, and then it's asking me if I want to remove it before installing. So it takes a few seconds, and then what you will see is that at the end of this, Google Cloud SDK is installed. Okay, so once that's installed, the last thing that you'll need to do is restart the shell or create a new shell for all the changes to be taking place. So I'm just going to close mine, and then I'm going to start up a new shell. So the last thing that you probably need to do is initialize your account. So you're obviously going to need to go onto Google Cloud to sign up for an account. So if you haven't got an account already, just go to console.cloud.google.com. There will be a sign up process that you will need to go through, and then once you're registered, you'll be sort of good to go. I've obviously got mine already set up, so I don't need to do that. But once you've got a new account created, then you can just type in gcloud in it, and then it will take you through the process of initializing your Google Cloud account, and it's going to ask for things like your username, your password, and all that sort of thing, and then it'll get you all connected up, and then you're good to go. So last thing I want you to know is once you've signed up and you're logged into your console.cloud.google.com, is if this is the first time that you've used Google Cloud, one of the things that you're going to have to do is you're going to have to enable billing. So you can see on my machine, I've already got billing enabled there. You see I've got no estimated charges, etc. But to enable billing, you're just going to click on the burger menu at the top there, and then click on billing, and then that'll come up there, and then it's going to give you the ability to sign up and enable billing. You'll need to put your credit card details and all that sort of goodness in there, but nothing will work unless you do that. So that's just something you need to do to get started. But once that's done, you're able to get going. So what we're going to do now is we're going to create ourselves a new GCP project, and then we need to do that before we can deploy anything onto Google Cloud, onto Cloud Run. So as you see, I've got a couple of projects already created, but I'm going to create ourselves a new project for this particular example. So what we will do here is I'm just going to click on new project. Now, if you're not sure where that is, it's just at the top level there. You'll see a list of the projects that you've got. So if you click on that, you can click on new project, and then it will prompt you. So you can see you've got loads of projects in kind of available. You can do something like 25 projects. So I'm going to give my project a name. I'm going to call it Cloud Run Actix Hello, so it's matching with what I had before. And then I'm just going to hit create, and then that'll take a few seconds, and then it'll go and create that project. And once that's done, I can then start to use that for my deployment procedure. Okay, so you can see that that's now done there, and you can see it's got a sort of project number here, and then it's got this project ID. So Chuck Actix Hello 1 is the current project I'm on. But that's not the one I created. The one I created was Cloud Run Actix Hello, so I can just use that little menu there to switch it across. Okay, so now that we're set up with our Google Cloud account, what we want to be able to do now is use Google Cloud Build, which is Google's built-in CI/CD pipeline to go and build our application. So rather than us building it locally, we can get Cloud Build to build it on Google's cloud servers, and then do that deployment to Cloud Run. Now, as it stands at the moment, I've got my Cloud Shell all set up, which is good. But what I want to be able to do is make sure that we're interacting with the right project. So if you remember, we created a project called Cloud Run Actix Hello. So what I can do is, if that's the only project you've got, it will automatically default to that project. But as you saw on my machine, I have multiple projects. So if I just do a gcloud config list, you will see that my current default project is Chuck Actix Hello 1. So one of the things that I can do there is, if I want to work with that new project that I've created, then what I can do is just set the default project. And I do that by doing gcloud config set, and then I can put project. So I'm saying I want to set this this key, which is project, and then I can put it to whatever I want. So in this case, I want it to be Cloud Run Actix Hello, and that means when I'm interacting with the gcloud shell, then it's going to work within the context of that new project that I've created, rather than use that as a default. So I don't need to keep specifying that all the time, but it's not going to use that project over there. So if I just run that for a second, and then if I do a gcloud config list again, you will see that it's now set the default project to Cloud Run Actix Hello. So that's all good. I'll just clear that, and then that's us ready to be able to kick off our builds with gcloud build. So now that's ready, there's one more thing that I'm going to need to do. So if I come back into my console cloud-google.com, one of the things I'm going to have to do is set up the right permissions, because I'm going to use Cloud Build rather than my local machine to do the build. So I need to set up Cloud Build to have the right level of permissions to do that. So to do that, what I'm going to do is go to console cloud.google.com. And then what I need to do is go to cloud-build and then settings. So if we just type in that, and then it's going to come back with all of the service account permissions for gcloud. So the first thing that you're going to see there, it's going to come up with a bunch of stuff, but you can see this information thing here. It says the Cloud Build API needs to be enabled for changing the permissions of the service account. So that's a starting point. We need to make sure that Cloud Build is actually API is enabled. So if I click on that View API button there for a second, there it is, Cloud Build API, and I can just click on that Enable button, and then that will enable Cloud Build API for me to use that from the Cloud Shell. So that'll take a few seconds, and then that will get enabled. As you can see from my machine there, it is now enabled, and the next thing that I need to do is ensure any service accounts I've got have been enabled also and have been granted access. So to do that, I just need to go back to Cloud Build settings again. So if we click on that, and then you can see that there's a little thing here called service accounts, and what I'm going to need to do is grant access. So I need to set service account permissions. So what I want to be able to do is enable access to all service account permissions. So with that done, that means I am good to go, and then I can kick off the builds from my machine. Okay, so now that we've got our Google console properly set up, and if we just recap that a little bit, we've installed the Google Cloud SDK on our local machines. We've created a new project on our Google Cloud dashboard. We've defaulted that project on our Google Cloud console so that whenever we submit commands, it's always using that project that we set up. And of course, we can change that easily. What we've also done is we've set up Google Cloud Build on our back end. So we've enabled API access, and the reason we need to enable API access is because our console here is going to access Google Cloud Build via the APIs, because we're running a console on my local machine. So once that's all done, and then we've given the service accounts appropriate permissions to access our Google Cloud project, so it's going to run with the correct permission set as we would expect. Then with all that done, I can now submit my build via the shell to be run on Google Cloud Build. And as I said, Google Cloud Build is a CI/CD pipeline. So what it's going to do is take the source code that's on my machine, and essentially it's going to build that upon Google's servers on Google Cloud Build. And then what it will do is it will create that container. So it will build that container, and we'll see that running. And then it's going to take the container that it's built and put it on Google's own container registry. And Google's container registry is called GCR.io, and I'll show you that in a second on the website. The way that Google Cloud Build works and Google Cloud Run works is it needs to use in the container registry, because GCR.io is an overall container registry serving all of Google Cloud accounts. Then the way that you specify that is you need to use the project ID as your organization, and then the name of your application for the repository. So, well, I'll show you what that means in a second. So to kick off that build, we are going to type in gcloud. We want builds, and then we're going to put submit, and then we're going to put in -- tag. So what we're essentially saying there is Google Cloud Build, I want you to create this build, and I want you to create a container, and I want you to stick it on this location. So in this case, it's going to be GCR.io. And if you remember, the project ID that we set up in this case is called Cloud Run Actix Hello. So I'm just going to put in Cloud Run Actix Hello for a second. And then, of course, if you remember the app name, so it needs the container name. It happens to be that I set the app name is the same as the project name. So in this case, it will be called Cloud Run Actix Hello as well. So that's how that's going to work. And then the last thing I need to do is I need to give it some sort of timeout, right? Because it's quite a long running application. So if during the build takes longer than the default, then it's going to crash out. So I'm just going to set a timeout of around 2,000 seconds, and I think that will be enough. And if I hit return, that is now going to take my application and it's going to build that on Google Cloud Server. So if we look at the shell command line for a second, you can see here what it's doing is it's creating a temporary tarball archive of 2,632 files totaling 570 meg before compression. So actually, that's probably the first thing to understand about this process. Is what it's going to do is locally it's going to grab all of the files on your machine, tar it up, and then it's going to send that tar up to Google Cloud Servers, because it's going to build that on Google servers, not on the local machine. But actually, that's probably quite suspicious in the first place, because I shouldn't have 570 megs worth of files, and certainly shouldn't have 2,600, 300. So what's going on here? Well, what's actually going on here is, although I've created a Docker ignore, Google doesn't use that Docker ignore. It actually uses a thing called gcloud ignore. So Docker ignore is great for when I'm running on my local machine, but I actually need a gcloud ignore so that it can actually not upload all of those files, because I don't want that target directory here, which has got all of my binaries, all of my dependencies to be uploaded with it. And then the last thing is, obviously I do want my Docker file to be included as part of that tarball, so I'm just going to remove that from the gcloud ignore, and I'm going to hit save. And once that's done, I will now be able to rerun that command, and it hopefully should be a lot quicker. So if I just run gcloud build submit, and now what it's now doing is creating a tarball of 5 files totaling 31k. So of course that's going to run much quicker now, because I'm only copying across the source files that I need and not all of my built files. So as you can see from this machine here at the second, it's going to take quite a long time, because it's going to have to go and pull down all of those layers it needs to do, and it's going to take a bit of time to do that. So we'll let that run, and it's going to build that, and then we'll see what happens. Alrighty, as you can see, Google Cloud Build has now built my application, but it's taken a huge amount of time. If you look at this, it's taken something close to sort of around 20 minutes to create the application. It started around 6 minutes past 6. It's now 28 minutes past 6, so it's taken around 22 minutes to do that build, which is a huge amount of time. So this is why I put a lot of focus on the beginning about these multi-stage builds, because you want to be able to make use of all the caching layers, etc., so that when you're building your application, it's not spending all its time rebuilding dependencies, etc., and it can build it super fast. And we'll come back to that in a second. But just before we do, just to prove that's been built, if I come back into my kind of Brave browser for a second, yeah, and if we were to open up a container registry here, and if I just click on images, what you should be able to see is there is Cloud Run Actix Hello, which is the registry which relates to the project that we had there. And then if we click in here, then there's the image that we built. And as I said, it's a very small image. It's 11.5 meg, and it's because I use this multi-stage build, which you can check out in the other video on how I managed to get that so small. So we've got an image deployed and up and running a container registry, which is cool. But as you'll see in a second, there's a few issues with that build, and we're going to look at how we can speed that up in a second. So you're probably wondering to yourself, well, why would I use Google Cloud Build to build my containers anyway? And you can use any CI/CD platform that you want to build that, but the reason I use Google Cloud Build in this case is certainly on my machine, because I'm running the Apple Silicon M1, then it's obviously my machine is going to default to an ARM64 architecture, and yes, I can mess around with that and set a different target to AMD 64, etc. But actually, it's a lot of hassle, and therefore, if you want a nice sort of super simple, forget about it, and then of course later on you're going to integrate it with your kind of CI builds, etc., then using something like Cloud Build and get that to deal with the target architecture is going to be quicker, and it means you're going to run into less problems. So I think it's good to get into that habit of CI/CD from the beginning, and therefore, using Cloud Build to build that is where it's fine. But again, you can use anything you want. I mean, there's nothing stopping you using things like Azure pipelines, or if you really want to sort of do it from your command line, you can do a Docker build, and then you can just do a Docker push. But just be aware, if you're doing it on Apple Silicon, when you do the Docker push, then it's not going to work for an ARM64, and then you're going to have to do multi-target builds, and it's going to be quite complicated. So simplest thing for you to do is just use Google Cloud Build, as I've done here. Okay, so I've got my image up and running, but actually I sort of want to make this point that we had before. So let me just clear that. If I do want to make a change to my application, remember when I did the Docker build on my machine? In fact, if I just do that, if I come back to the Docker build that we had done earlier, if I run that again, right, rather than taking the 2 minutes that it took, it would actually only take around 7 seconds. So, and that's because it's using all of these caching layers, and therefore it's going to become super fast. And that's why I use that multi-stage build. Now, the problem that I'm going to have here, as you're going to experience, is if I do that gcloud build submit again there and hit run, then I would hope that it's going to use all of the caching layers. But actually, in reality, by default, it doesn't use all the caching layers, and therefore it's going to start doing everything that it did before. So we'll see that in a second. So as you can see from the build there, even though I've pre-built that image, it's got the ability to support caching and multi-stage build, it's off and it's re-downloading everything from the scratch. So I'm really not getting the advantage of my multi-stage build there. So what I'm going to have to do, let me just kill this for a second. What I'm going to have to do there is use another feature of gcloud, and I'll show you what that setting is, and that's going to make your life a little bit easier. So the way to handle that is you want to use a thing called kaniko, and kaniko is something that runs in Google Cloud Build, but essentially it's a caching layer. So by enabling kaniko for your builds in Google Cloud Build, what it will mean, it will cache those underlying layers into storage, and then that means next time you build, if you haven't changed dependencies, etc., then it can just use those cache layers, and then it's going to get back to just building your application. So we will set that up, and we will do a gcloud config set builds use kaniko, and we're going to set that to true. So if we just set that, and then it's good. And if you want to check what your kaniko status is, you can do a gcloud config list, and then it'll tell you here use kaniko equals true. And of course, this is the same command we used earlier to check and set what our default project is. So that has been done. So I'm just going to clear that, and then what we'll do is we will build the application again. It's going to take the same 20 minutes or so that it did the last time, but once that's built, for me to then do an update after that, it's going to be super quick because it's going to start to use those cache layers. So I will just kick off that build. And then by the magic of editing, you will see that it's been built super quickly. So it's going to do that build, and then we will make a change to the application, and we'll build it again. As you can see now, Cloud Build has finished the build of the container, and if we look underneath here, you can see it's taken 23 minutes and 28 seconds. So it's taken a super long time for that first build. But as I said, the beauty of kaniko is it caches the layers. So whenever I do a second build, etc., it's going to run at super fast speed. So let me just prove that. So if I just clear this, and then if I do my gcloud build again, what you're going to see now is going to run much faster. So it's going to use all of those caching layers, and again, we will see how quickly that is. There you go, and as you can see, it's completed the build, and this time using kaniko, it sped it up from 23 minutes, and it's now running in 1 minute and 43 seconds. So and this isn't just a Rust thing. This is the same whether you're using Dart, whether you're using any build system at all. Using kaniko allows you to increase those caching layers, and it means it's going to super speed up your build time. Now, of course, in particular case for Rust, because actix-web takes such a long time to build and run, then because it's got a lot of packages to download, then as you see, you're getting a huge improvement in build time performance, bringing it down from 23 minutes down to 1 minute 43 seconds. So I super recommend that you've done that. So we are done with the build stage. So we've now got a Google Cloud Build up and running, and we can build our containers super fast and super quickly, which is good. Now we can move on to Google Cloud Run and see how we can take those containers and then actually run them within the Google Cloud Run environment. So what we're going to do is come back to our browser for a second, and actually we'll just come back into our container registry one more time. So if I go to container registry and have a look at the images again, and we go back into Cloud Run Actix Hello, you can kind of see that there. There we go. There was our build 1 minute ago. That's the one that we just did, and again, it's 11.9 meg in size because we haven't made any changes there. But you can see the earlier versions of our image 5 minutes ago, 36 minutes ago. They all reside within our build as well. So we still have access to our previous builds, but you can see this is marked as the latest one that was done 1 minute ago. So good news is we've got our image. It's sitting in the back end there. And the last thing I want to just see there, you can see this folder called cache. If I just open that, you see all these cache layers. Well, guess what that is? That's our kaniko layers. Remember I said enabling kaniko means it's going to cache the underlying image layers so that it can speed up the build. That's where it's storing it. It's storing it in the Google container registry as sort of cache layers there, and then that means it's going to speed up that build. So as I said, where are we now? We've got our built application. We're in a good spot. So what we want to do is take that container that we built and now run that within Google Cloud Run. So to do that, there's multiple ways of accessing that. If you just want to access it from the console, you can just go to consolecloud.google.com/run, or alternatively, you can, if you're already in the burger menu, you can click on the Cloud Run piece here. So as you see, I've clicked on Google Cloud Run. And it says run containers on a fully managed platform, get started by creating a service, right? So I don't have a service created just now. Now I could do this via the command line, but I think it's going to be a better thing to do it via the web browser in this particular case. So it's good to set it up and then do future deployments via command line. So it says click and create service will enable the Cloud Run admin API. And then again, that's another thing you need to be aware of, is that, like Cloud Build, the admin APIs and all that need to be enabled. So I'm just going to click create service, and then it's going to do that enablement. And then as you can see here, it says a service exposes a unique endpoint, blah, 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 and it handles incoming requests. So service name and regions can't be changed later. So what we will do is it wants to know a container image URL. So I can sort of click on this. If I hit the select button, you can see it gives me access to my container registry, and it's defaulted to Cloud Run Actix Hello, which is the one that we had earlier. So if I wanted to switch to another repo, I could go to one of these other repos that I created earlier, or organizations that I created earlier. But in this case, I like the default being Cloud Run Actix Hello. That's the one we're using. And then if I expand that node out for a second, you can see there's the various images, and I can select the latest image that I want. I can select what there. So in this case, 6B blah 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 is the latest. So I can just hit select, and say this is the version that I want to run. Now, if I want to, I can set up continuous deployment from a Git repo, so I can connect it up there, but I'm not going to do that, but I can do it if I want to. You would just click on that, and then you can set up Cloud Build, point it across to your GitHub repo or Bitbucket or whatever, but I'm not going to do that. I'm going to just do the sort of one deployment. I can pick my region, so depending on where I want to be, in this case it's defaulted to Iowa. It's low for carbon emissions. If I'm in Europe, which I am, then I could pick something like London or somewhere else. I don't really mind where it's being set, so I'm just gonna stick with Iowa. I mean, if I was being strict, the people who are accessing could be close to me in London, but to be honest, people who watch this channel hit across the world, so I'll just stick to Iowa. That's fine. And this is what I was saying about serverlessness as well. So if you see here CPU allocation and pricing, it's two options. CPU is always allocated, so you are charged for the entire lifecycle of the container instance. So that means that your container is going to be running essentially all the time. Or this one, CPU is only allocated during request process. So this is what I was saying before, right? Which is about Cloud Run being properly serverless and being able to scale down to zero. So essentially you only get charged for the request it makes. So as the container is running during requests, then that's when you get charged. And it relates to this sort of auto-scaling thing. So you've got a minimum number of instances. So in this case it's 0. So if I want the ability for, let's say I've got large periods of time where I'm getting no requests, and I want the containers to spin down to 0, but then wake itself up on a first request. So maybe I only get requests between 10 o'clock and 2 o'clock. Then, for all periods of time, if I have a number of instances set to 0, then it will just scale down for the rest of that time and not actually be running, and then I don't get charged. But there, as I said earlier, there is a sort of trade-off in this case that if I've got my instances to 0, then it's going to take that first time that it restarts, it's going to take a little bit of time, right? And therefore, that's what it means by cold restart there. And then that first hit is going to take a little bit longer. Whereas if I don't want that sort of extra sort of cold start time to be included, I can leave instances running all the time. So I don't mind it being set to 0. That's sort of good. So we can sort of leave that there. I guess if you were being super strict and you wanted redundancy and sort of high availability, then you would set your minimum number of instances to 3, because then that's going to up your instance time. But in all honesty, 0 is good enough for me, and then there's a maximum of 100. Ingress, again, allow all traffic, allow internal traffic and traffic from cloud load balances, or allow internal traffic only. So again, when you might want to use this, I'm building a web server in this case, so I want to allow all traffic. But if I was doing something slightly different, so let's say I was doing event driven rather than web servers, and I was just reading off of of some sort of event stream, then in that case I might want to allow internal traffic only, right? And therefore, some sort of event occurs, I spin up my container, do what I need to do, and spin back down. So I wouldn't want access to the outside world. So that would be an example when I want to do that. And then the other one, allow internal traffic and traffic from cloud load balancing. So I may have some sort of specific setup where I'm running my containers, but I'm controlling access via cloud load balancer. So that would be a situation where I would select that. But in this case, I don't really care. And then the next one is authentication. So there's two options that I can have. One is I can just make it public. In this case, it's a public API I'm creating as a public container. I want unauthenticated traffic to hit it, so I'll select that. But let's say I want to build a container that only authorized users can access. So I can then say fred@fred.com or whatever. So I can use my cloud identity access management built into Google Cloud to restrict it to specific users. Good examples where I might want to do that is if I'm restricting traffic just to those specific users. Maybe I'm doing a beta build, or maybe I'm doing some internal testing or something like that. That would be a good use case for that. And then of course there's all of the kind of container variable secrets and all that. So you can see there's the default container port 8080 that I explained earlier. That's why we configured, if you remember, because it's going to pass in listening on port, but as I said, we configured our machine so we listen to this port environment variable. If I change this from 8080 to 3000, our application would still work, because all this is doing is setting the environment port, and then that's going to get passed through in a container startup. So we're able to deal with that. And then of course there's memory allocation. So in this case, I don't need 500. You could go up to 16 gig here. Ours is a fairly small app there, so I'm just going to set my memory to 128 meg. I don't need to put much CPU on that, so actix-web is a super fast web server, so I'm going to keep the number of CPUs down there. And then you've got maximum requests per container, so that's the number of concurrent requests can hit container. Again, I think it supports up to about 1,000. 80 is fine. actix-web is super fast, so I think that will do there. And then you can sort of select what execution environment. You can pick first gen or second gen. So second gen's under preview at the moment. Is slightly faster. So they've done some improvements on cold starts, etc. Full in its capacity. It's up to you what you choose there. I'm just going to select default because I don't really mind too much. And then I'm just going to hit create, and then that will go and create my Cloud Run application. So we'll give that a second, and then that'll be up and running, and then we're going to hit our endpoint. Alrighty, so as you can see now, my container is now up and running. In fact, if I were just to click copy to clipboard here, you can just see here the URL, Cloud Run, actix-hello, blah, 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 blah. That is the URL for my application. So by clicking this, and then if I open my new browser tab and paste that in, and then if you remember, if I put /hello, it's going to run my application, and there you go, you can see hello world. And like before, if I pass in something like Chris, you can see it's going to come back with hello Chris. So there we go. It is super simple to get a container up and running on Cloud Run. There's a little bit of complication about some of the setup. There's a little bit of complication around configuring things like Cloud Build, for example, and getting that running super fast that we did. But once that's done and you've got a container up and running in your container registry, you can see it's super easy to get up and running. And that is probably the key thing there, right? Is I built my container, and I built it in a way that I would normally do on my local machine. So it's just a standard Rust application, but there it is running on cloud infrastructure. And again, if I click on here, you can kind of see, it'll come up with the metrics in a second, but give it a little bit longer, and then you'll see that it's got all the metrics, and you can see the requests per second. If I click on logs there, same sort of thing, it will start showing any logs associated with my application. So in this case, you can see there it's received a get on the hello, and there's the request that I made a second ago. So you see it's ran, Cloud Routes is run, and there's the hello Chris. And if I were to change that to hello Fred, click that, it says hello Fred. And then if we come back on that, give it a little bit of time, and then what's going to happen is there it's appeared now. You can see the hello Fred appeared in the log. So we've got fairly real-time enough access to the logs. There's nothing too exciting on the revisions at the moment, because I'm only running one version of my application, and we'll go into sort of what that is in a second. You see 100% of the traffic goes to that version that I just deployed. There's no triggers or anything like that goes on there. And then, as you can see, there's the YAML file. I'll explain what that is in a second as well. And again, if I come back to the metrics, it's fairly light on that just now, because it hasn't really done anything. Let's bring it down to a 1 hour period. There we go. You can see I've got this one sort of hit there, and it's responded to that request with a 200.167 seconds. And then you can see there's my latency. So it's a fairly fast. It's coming back in sort of 4 milliseconds, which I would expect, because I'm running Actix, which is one of the fastest web frameworks that you can imagine. And you can see my container memory utilization is tiny. It's sort of 5%. So that is my application up and running on Cloud Run. Now, if I wanted to, what I could do is I could send a bit more traffic through, and then we can see what that looks like. So what I'm going to do is I'm going to come back to my application for a second, back to my terminal, sorry. And what I'm going to do is send a little bit of load there. So I'm just going to type in WRK. And WRK is a load testing tool. So I'm going to send some load to it. I'm not going to send a massive amount of load, but I'm going to send some load, right? Just to see how that is. I'm going to limit it to 256 connections. I'm going to run my test for about 30 seconds. And then I'll just pass in the URL. So we'll put hello WRK just so we can see that in the log file. So we'll just run that. And it's going to run a 30-second test, and all it's going to do is just send a shed load of requests there. Now, I'm not going to get a massively fast response from this, because remember, I'm running just outside of London at the moment. My containers are running in Iowa, if I remember. I've got restricted connections. It's going to take a little bit of time to get that up and running, but I would still maybe expect to see a few hundred, maybe 1,000 requests per second. There we go. So I've got about 1,600 requests per second, which is probably about right. So If I now come back into my browser, and if I come back to logs, we'll give this a second, we'll come back to metrics. You can see there's all the requests that I made. So we've got a lot more happening. So you can see everything's hitting this hello WRK. So that's cool. We know that's logged all of this. And then if we come back to the metrics in a second, the thing we will have a look at, you can see I've got one container running at this point. The request count is fairly low at this point, but once this updates itself, then we should see a higher number of requests, because for that sort of 30-second period. So we'll just give that a second. Alrighty, so the metrics have now updated itself, and well, let's take another quick look at what's going on here. So as you've seen there, I had no requests coming in, and then I ran my WRK tool, and then very quickly you can kind of see that containers started, or my service started running 790 requests per second for a little bit there, and then as you can see, it sort of spun back down. So this really short spike. So as I said, I only ran my test for about 30 seconds. It handled that traffic, and then you can see the requests per second came right back down, and that's because I stopped running the test at that point. Probably what the interesting part of this though is actually you can see a really interesting thing, which is Google automatically scaled my application. So it spun up 12 container instances to deal with that. Now, and I know that Actix can handle that level of requests really easily, but for whatever reason, Google decided I'm just going to spin up a load of containers. So it spun up a load of containers to handle that, which is sort of 12, 13 containers. They're still running just now, but then what you're going to see is in a second, that's going to spin back down. And now, of course, what that means is from a billable perspective, I'm going to be paying for those 13 sort of billable containers to run. So one of the things that I may wish to do in order to save my bill when somebody hits us really hard is I might want to be able to configure my application so that it doesn't run out of control and just spin up instances whenever it gets a load of traffic in there. So why don't we do that, and then what we will do is then see what the impact is. And there you go. My metrics have just updated a second there. So you see it ran at 13. And then now it's sort of down to 0. So there's some containers still running idle, but this is what I was saying about serverless. It's sort of spinning up and then spinning back down again. So what I'm going to do is I'm just going to click on this edit and deploy new revision, and what we'll do is update our settings to see if we can handle our billing a little bit better. Now, the first thing I want to say here, if you look at this, is remember it spun up to something like 13 containers, but part of this is because of this limit here, which is the maximum request per container. And you can see at the moment it's limited to 80 requests per container per second. So, or concurrent requests, not per second. Yeah. As you can see, it's limited to 80 concurrent requests per container. So if you go above the 80 concurrent requests, what it's going to want to do is spin up another container. And you see I've limited this to between 0 and 100. So if you remember, we were running something like 1,000 odd requests or 800 requests per second on the back end there, even though WRK was sending around 1,600 requests per second. In the back end here, we were handling about 800 requests per second, if you remember. So if I sort of just run a quick bit of maths there, if you do a sort of 800 divided by 80, then what you're going to end up with is roughly around that 13 mark, which is what it sort of scaled up to. So there's a couple of things to think about here. This is where it runs slightly out of control, right? So I've got this combination of 80 and 100. I could end up in a very expensive situation, right? So if I've got 100 container instances running all at the same time, that's going to get very expensive for me. So one of the things I would say is have a thinking about your billing and how much you want to be spending. So in my case, I don't think I really want to be going beyond 3 instances, right? Yeah. So So I don't really think I want to be going much beyond sort of 5 instances, right? And actually, if you have a look at this, you can see you can't have less than 1 instance there as a maximum. This is a really interesting message. You see, revisions using a maximum number of instances of 3 or less might experience unexpected downtime. And the reason it's actually saying that is that in order to guarantee high availability, especially for deployments, etc. If you're limiting the number of instances, then it can't spin up and spin down, etc. Because it's sort of limited. So if you're going sort of 3 or less, then Google's going to have trouble keeping your service up and running. But if you've got a value such as 5, for example, or 4 or whatever, then it can manage the number of instances to keep your applications up as it's doing things like spin ups and spin down. So in this case, I'm going to limit the number of instances to 5. But then what you're going to find is by doing that, what you will see is that my request time will take longer, right? Because, you know, if I've got the 80 and I limit my instances to 5, then it means that I'm going to be running no more than 400 requests per second. So because Actix is a super fast web server and can handle way more than 80, then I could up this number. So, but I won't just yet, right? What I'm going to do is I'm going to save this, and then we'll run that test again, and we'll see what the impact is, and we'll see that it's going to be limited to the 5 instances, and you'll see it'll cap there, and you'll see the latency will take a bit longer, and then we'll open it up a bit by changing the maximum request per second. So I'm just going to hit deploy, and then you can see serve this revision immediately. 100% of this traffic will be migrated to this revision, blah blah blah, overruns. So I'm going to say yes to that just now, so I'll hit deploy. Okay, and now it's deployed. And the thing I want you to see is, if you look here, the traffic is now 100% to this DIZ, right? So before I was running on CIJ. So as you can see, what's happening in the background is it's down the traffic from the previous instance and it's up the traffic to the new instance. So if I were to go back to my application and then I'm just going to run at the same test, so I'm going to run this for, let's run it for 60 seconds rather than 30 seconds. So we'll just do that. And so it's going to run that 1 minute test. And again, I can, if I click on the URL there, you can see it's still working there. And then if I type in Chris, you can see hello Chris. So my application's still up and running. Alrighty, so there's a few things to notice here, and I want to have a look at this here. So this is a previous test, if you remember, where I ran it for 30 seconds, and you know, you can see it's done pretty well. It's at sort of 800 requests per second, roughly there, and here it's around 1.2. You can't look into that too much there because that was a 30-second test and this was a 60-second test, but it doesn't really matter. There is a few things I want us to look at, which I think is more important. In the previous test, we went up to that sort of 13 active containers, if you remember. But if you look over here, in this test, you can see at maximum I've got 4 active containers. So that limiting where I set my maximum number of containers meant that Google isn't spinning up loads and loads of containers and going crazy, and therefore hitting my sort of, giving me potentially a large bill later on. So again, I think that's something just to be aware of, and I think that's kind of good in that sense to have control. But there is an impact on that, right? And the first impact, as you can see, is my CPU time has went up. So in the previous test, my CPU was hitting around 23% CPU in my containers. But actually, in this test, I'm hitting about 50% CPU because I've got less containers running and therefore I'm hitting them harder, so my CPU's going up. The other thing that I think is important to note is the latency has gone up as well. So you can see here, I had a very small latency. I was running at sort of around 4 millisecond latency. But here in this test, it's running at around 28 millisecond latency. Why is that? Well, it's coming back to, remember where we had 80 requests per second. So I'm running a maximum of 80 concurrent connections per container. In fact, we can come back into that. So if we just open up edit and deploy new version. So if you remember, we have 80 maximum requests per container, which is what we had before. And then we're limiting the number of instances to 5 as a maximum. Well, that's giving me a limit of around 400 concurrent connections at that point. So on the fact that I can't go beyond that sort of 400 limit, in fact I think it was less because we were running 4 instances of a container, because I can't go beyond that, then it can't spin up any new instances to handle that traffic, so it's just taking longer to serve it. So even though I was running that test for sort of 60 seconds, which is fine, it meant that it wasn't responding straight away because the container was having to finish the request it was dealing with. So that's why one of the things I could do here is up this to 1,000 requests per container, which is the maximum. Now, this is one of my frustrations about Google Cloud Run, because if I try and do higher, you can see it says choose an integer value between 1 and 1,000. So I can't go higher than 1,000 requests per container. But I'm using actix-web, which is a super fast web server, which can handle way more than 1,000 requests concurrently. So therefore, Google is constraining my container, because potentially I could be handling a lot of that connections with one container, but it's not letting me do that, and I'm maximizing to 1,000. Okay, so I've shown you how you can kind of build from Google Cloud, how to scale up, scale down. One of the things I want to show you is how you are then able to sort of mess around with traffic. So what I want to do is go back into Visual Studio Code, and then what we're going to do is we're going to make a change to our application. And in this case, rather than saying hello, this is going to sound weird, but we're going to say goodbye now. So we're going to build a new version of our application, and rather than saying hello, whatever the name is, we're going to say goodbye instead. So I'm just going to save that. And then what I'm going to do now is I'm going to do my build again. So I'm going to do a gcloud build submit. And that is, as it did before, what it's going to do is take all of those files, it's going to upload that as a tarball, and then it's going to go and build that on Google Cloud Build. Alrighty, so now that the application is built, let me just clear all of this for a second. What we will now do is just deploy our new version. So what we will do is just hit edit and deploy new version. We're going to change the container image, so we'll just go into here, and you can see we want our latest container. We're going to leave everything as it was by default, and then what I could do if I wanted is, rather than serving the revision immediately, I'm gonna unclick this. I'm just gonna deploy it, but I'm not gonna move the traffic across. So I'm just gonna hit deploy, and as you can see, my application is now deployed, but the traffic is still at this Cloud Run hello 005. So if I was to let's say change this, and we'll say hello Stephanie, and you can see it says hello Stephanie. So even though I built my new application, it's still going to Stephanie. It's still saying hello and hello Stephanie, and the reason is none of the traffic is going to that new container that I sent. It's still going to the old version, and that is useful for deployments, because if I want to then start moving traffic around, that becomes nice and easy to do that. So if I click on this manage traffic piece here, and you see I've got revision 1 is serving all of the traffic, but if I switch revision 2 to latest healthy revision, and I can pick anything that I've deployed before, so let's say latest healthy revision in this case, and what I want to do is move this to 100% of the traffic, and then I'll hit save, and that'll take a second. And you will then see that once that's done its change, the ROF is now taking all the traffic. So if I were to call hello Stephanie again, you can see it says goodbye. So it's switched automatically to my my new version. Now, if I want to do, if I want to switch traffic back to the previous version, then I can go back into manage traffic, and then I can literally just go 100%, and we can then just changed that back to the previous version, which was the HUN version 005. And then if I come back into here and then hit that again, you can see it's back to hello Stephanie. So what does that allow me to do? It allows me to run multiple versions of the same application. I can have them run in parallel, and then I can use traffic allocation to switch between the two versions. So 100% here or 100% there. So it makes it really easy for rollbacks. Now, if I want to get into a world where I start doing A/B testing, blue-green testing of builds, then I can obviously split my traffic. So what I could say is I want 50% going to, the HUN version, and then 50% to the healthy revision. And I could do 10%, I could do 100%, whatever, but let's do 50-50 there. So that'll update in a second, and then you can see that once this updates, we'll have 50% and 50%. Yep. And now if I come back into this, and where it says hello Stephanie, let's put a new name. Let's put Teresa. Yep. So you can see it says hello Teresa, but if I hit refresh and then it's goodbye Teresa, hello Teresa, goodbye. So it's switching between the old version and the new version. So if I want to start doing that sort of green-blue deployment, see if my application's working, see if I've got any log errors, then I can do that. So as you can probably see, it's going to be super useful for managing the deployments of my applications. And again, I've shown you that with through the website, but again, I can do that through the Cloud Shell as well. So I can do that via my my G-Cloud command shell as well. I'm not going to go into that because I could spend ages sort of switching between the various versions. I think the last thing that I wanted to sort of show here, again, I'm not going to mess around with this in the console because it's going to take quite a bit of time. But remember, everything that I did on these service deployments is actually able to be set as a kind of YAML file, and you see in the back end, as I mess around in the console, it will actually create a YAML file for me. If I want to, one of the things that I'm able to do is download that YAML file. I can put that YAML file in my source code directory, and then if I want to, I can use that to configure things so that I'm not doing that via the console or via the kind of deployment shell. So if I want to use YAML files as deployments, then I'm able to do that. And you can see that's where I can sort of specify CPU limits, memory, etc., how much traffic percentage is going there. So if I want to get into being able to control everything via configuration and get into that GitOps manner, then I can use the YAML file to do that. So there's lots of options within Cloud Run to be able to utilize your solution to be fully automated with CI/CD. Anyway, I think that's going to be the end of this video. I could probably spend a long time just showing you every detail, but I think in summary, I want to say a few things, right? Google Cloud Run is really cool. It's, as I said, it's a serverless container runtime environment. I can build Rust, I can build Dart, I can build Node.js, and I can do it in a serverless way. I can scale up to a high number of instances, or I can scale it down to 0 and then only be charged for when my requests are being hit, right? So when I actually have requests on my system. So it gives me that sort of flexibility of scale. Google does a great job of managing all of this, so it deals with all the fault tolerance, the scale up, scale down. I can manage traffic, I can do blue-green deployments, I can tag my images in a certain way, I can move traffic between everything. It's got good logging, it's got good metrics, etc. I can set up CI/CD, I can build from Google Cloud Build. It really is a great way of running my applications in a serverless manner. There's a lot of details to go into, but I think that if you have a Rust application, if you have a Dart application, and you want to get into the world of containers, build your containers and then throw it over the fence and forget about it, then it's a great thing. As I said, the only thing I'm not a big fan of is I don't like the request limits, because that kind of limits the ability that I have in things like Actix. So if I was to really open up the number of CPU instances, etc., then I would be hitting against that kind of 1,000 concurrent request limit, whereas I'm not limited in other container environments. But again, do you know what? Maybe it's not a bad thing, right? Maybe you should be using more container instances and not really thrashing your containers. So a little bit of experimentation for you and your applications. But as I said, good serverless environment, fairly easy to use. And the nice thing about it is that you get to build your applications in the way that you want, right? But put the container behind that, and then you can fire and forget and have it managed in that environment. So anyway, I hope this has been a useful video. Again, if you want to get into Cloud Run, maybe use it with Rust, but everything I've showed you would work with Dart, it would work with Fastify or other applications. Hopefully it gives you a bit of an interesting primer, and then I'll catch you on the next video.